Let me start with the transport layer module, and today I'll talk about the roles and functions of the transport layer protocol. Transport layer protocol is in business of somehow receiving data from the application, doing something with this data, and pushing this data as packets to the network layer protocol. And it would be network layer protocol business to actually figure out how to deliver those packets between different hosts. And as soon as this packet arrives to the destination host, it will be again a transport layer business to figure out to which specific application this packet belongs to and how to kind of do some magic to actually get this data back to the application. And you already know several of these transport layer protocols, TCP, UDP are the classic ones. I was talking about the RTP protocol in the context of the application layer, and same for the QUIC protocol, but they also have some aspects of the transport layer protocols as well. If you're interested, there's multiple protocols that are defined in this etc protocols file that I mentioned on the slide. So you can take a look. The same file technically exists also on the Windows system, so you can take a look in this location as well. UDP and TCP are two classic transport layer protocols. UDP just providing the multiplexing and demultiplexing capability that I will talk a little bit more extensively later. And TCP protocol provides additional mechanisms like a connection setup, flow control, and congestion control. And several flow control is effectively ensures that the data is being delivered reliably, and the congestion control ensures that you don't send too much data to overwhelm the network, and because it can cause very, very negative consequences. So the basic need for the multiplexing and demultiplexing, already a little bit highlighted, it comes from the fact that multiple applications want to communicate, be it on the same host or different host. And what you need to have with this, you need to have at least some form of identification. Because after they leave the transport layer protocol, they all become part of the stream of the network layer packets with just the destination IP address in there. How exactly this identification happens really depends on the transport layer protocol. So it can be some form of a session ID, and this is exactly what we're going to be doing as part of our project too. But the classic transport layer protocols like TCP and UDP, they simply use IP address from the network layer and port number from the transport layer protocol, like using either tuple or a little bit more complicated than a tuple. Applications normally don't deal too much directly with this identification information. In many cases, this information is being generated automatically. There is some form you still have to provide when you kind of write in the application. Like for example, when you created the server, you had to specify IP address and port to listen on. But when you accepted the connection, you didn't actually do anything else to, with the port numbers of the other system. And when you did this similar operation on the client side, you only provided the destination IP address and destination port, but you didn't provide anything about the local stuff. Something happened automatically. The interesting part regarding the server application, and I think for the client application as well. So there is a thing called in kind of the thing exists inside the operating system to allow this demultiplexing to happen in the first place. Kind of an abstract, you can think of some form of a table that exists inside of the kernel of operating system, which been consulted every single time the packet arrives on the system, and this packet destined to the system, and the packet is of a specific transport layer protocol. This table is simply a mapping between a socket ID representing the application itself and some information. I'm trying to be as vague enough here as to say, because it really depends on the transport layer protocol, the information that contained in this table can be different. If it's a IPv4 UDP protocol, then it would be IPv4 address and port number. If we're talking about the TCP, then there will be actually much more information in this table. To give you an analogy of the real life, you can think of the condo building and the kind of mail room. And whenever the mailman comes to this mail room, it effectively has the kind of table of the mailboxes where he starts dispatching mails, postcards. To start with the UDP protocol, to give you just basic idea, So again, UDP provides just basic best effort service. It doesn't really guarantee anything that if you send packet that it will be delivered on the other side. It's merely providing this mechanism to send packet between applications. That's the only function. That's bare bone function, doesn't provide anything else. There is one small thing in addition to that is additional checksums, but it's even those things not really used nowadays because packets either being delivered intact or not being delivered at all. And again, no connection service provided by the protocol, but you actually can have application level some kind of either session or connection, but really this really depends on the application. And there are tons of uses of UDP protocol. I just highlighted two, but there's many more that in existence. And our project 2 will be effectively using UDP protocol to build our new transport layer protocol. So it's kind of a little bit weird position of our confunder protocol on the stack. One thing that I have to note here is the identification. So I already highlighted a little bit, but I just want to make sure that you remember. UDP protocol identifies using just tuple of two things, as a port number and IP address. So these are two things, depending on which system we're talking about. If it's a server, then it would be which packet we're talking about. It's if packet destined to us, it would be destination IP address. If we are sending packet, that would be source IP address and source port. But in any case, because of this identification, one socket, like one BSD socket that you can create that associated with this port number and IP address will receive packets from any other IP address and port numbers. So it doesn't matter what is the source IP address and source port of the packet arriving on the system, it will be delivered to that socket. So the picture is quite different for TCP. And to give you just a specific example of this demultiplexing and processing for UDP, again, there's a table somewhere inside the kernel that has the socket file descriptor, which exactly represents some specific application, or actually this descriptor inside the application. And literally IP address and port number, and that's it. I gave you examples of how you can actually access this information in your operating system. So you can just run this netstat command and for IPv4, IPv6, and get all the information. One thing that I would like to note here is this special 0000 address. So this one is actually not real IP address, but rather a wildcard that you can specify to kind of describe, to tell the system that you would like to listen or to receive packet on any IP address that your system has. So this is actually was the requirement for the project 1, and not everybody went with this requirement, but it's also a requirement for project 2. So whenever you're listening or binding to the local socket, please specify this special 000. If you don't specify, then you effectively gonna restrict what packets, kind of destination IP address of the packets that are arriving to be to some specific interface on the system, and which potentially can fail some of the tests. Another difference that exists in UDP is the way you deal with sockets. So with TCP, you just use send and receive, and in addition to connect, listen, accept. With UDP, you don't have connect and accept and listen, but rather you have create a socket, you have to bind to the IP address and port number, and then you have to use specific form of send to and receive from. Because when it's if you want to send packet, you actually have to provide where exactly you want to send this packet. With TCP, that was part of the TCP connection. For UDP, there's no such thing, and you have to do it yourself. And to receive the packet, you have to specify from where you want to receive the packet. Otherwise, you receive from any destination that is sending packets to you. Okay, moving forward to TCP. So TCP, as I said, provides the guaranteed service. So it provides this flow control property. It provides you a connection. So you have some form of negotiation to actually create this connection. It provides the congestion control, kind of to ensure that you don't send too much data. And it's also actually giving you the full duplex data delivery. So it's so server can send data and the client can send data. So data can flow in both directions. But logically, it's actually just creating a stream in both directions, like two streams, two unidirectional streams. What I want to highlight with this packet header that I'm showing on the slide is the complexity compared to UDP protocol. UDP protocol was very, very simple. The only thing beyond the source port and destination port was some checksum and length. Here we have way more fields that exist in TCP packet header. I'm going to be talking more about individual packets in different modules, but right now I just want to highlight this complexity. Already mentioned, but to highlight again, TCP identifies kind of connection itself using 4 tuple. So it's using all information. It's a source IP address, source port, destination IP address, and destination port. So all these 4 items are used to identify the whole connection. And there's a small caveat to this. If you have a TCP socket that is in listening mode, so this is not really yet a real TCP socket and cannot be used for communication, that one actually exists in a half broken or half working mode, and you cannot really identify anything. But as soon as you created the connection, as soon as the connection been established, either you accepted it or you created it or you connected, now you have a TCP socket that is associated with all 4 parameters. And again, like to give you the same picture, you can access this information also with a net-stat command, just specifying TCP protocol instead of UDP, and it will give you much more detailed information. In here, I'm just highlighting effectively just 2 items, just showing that there's for one of the connections, there's a source IP, source destination, source IP, this source port, destination IP, destination port. And so that's kind of real connection that's been established. And there's one connection that has a wildcard for the destination IP and destination port. So those simply identify that this is still in listening mode. And kind of the interesting part of the net-stat command is it will actually give you additional details of what the state of the connection. Besides listening and connected, there is a bunch of more states. I think that this more than 10 definitely, and we'll talk about this more in a little bit more detail. Okay, so I hope I give you reasonable summary of the transport layer protocols. Again, the transport layer simply provides the logical channel between application, and to do so it has to have some form of identification. Depending on the protocol, there are different types of identification, and I talked about the identification in UDP is just 2 pieces of information, IP address and port. For TCP, for the whole connection, identification information is 4 items. It's the source port, the source IP, destination port, destination IP. And for different other transport layer protocols, this information can actually be different. And as you can see in your project too, there's also a thing called the session ID. And some other protocols can imagine something else. The core function of transport layer protocol is to do this demultiplexing, multiplexing. This is all about this addressing that I just mentioned. But in addition, some of the transport layer protocol provide additional functions, such as a connection management, flow control, which effectively reliability, and congestion control. And 2 protocols that exist, like the most common protocol, are UDP and TCP. Okay, so that's enough, and we have a lot more information coming in the next parts. Bye.